We've got another section here on quadratic word problems, and this is easier than the last one. I think this is the easiest of word problems, quite honestly, because they're going to give us the formula, and all we need to do is understand how a parabola, how a quadratic equation works. So let me get into it here. So do you remember, we know, is that what they're doing here? So we know this opens upward. Does that make sense? Because we had a 1 in front of the x squared. We know this is up. Now, that makes the vertex to be a minimum. Do you see it would be the lowest part on the curve on the parabola? So if you open upward, then you've got a vertex that's a minimum. If you open downward, then your vertex up there is going to be a maximum. And so you know that this is going to help us infinitely in these applications, that if you're right side up, you've got a minimum to deal with. If you're upside down, you've got a maximum to deal with. So I'm not going to work more of these. Let's get to the word problem. So my point here is this is once again upright, so we would have a minimum. So it's a u, so that vertex would be a minimum value. Do you see now this would be a maximum? It's going to be upside down, so that point is going to be a max. Okay, now let's get into why this is useful. We're working one of those projectile problems. We solved this in the earlier section. Something is being launched and it's going with that arch. Now, we know this arch is upside down because it's a negative. So this point right at the top of the vertex is going to be the highest point the ball ever reaches. So they're going to ask us two things. They're going to say, okay, when were you at that highest point? And what is that highest point? Well, that's the x and y. In other words, you're being asked to find the vertex. So here we go. So yeah, I don't like that to do this. The initial velocity is 176, so I'm putting that in. They're telling us the initial height. I wish they would just give us this without it. So I had to put 176 in for V naught and 4 in for H naught. That's all. Okay, now I've got the parabola and I know it's upside down. So if I solve this for t, I am finding, so if I find this right here, the x component of the vertex, I am finding the time that it's going to reach its maximum height. It's just the same thing we've been doing. Now the second thing is going to say, okay, well, how high was it? Well, you just put that height into the equation, and you now, or put that time rather, into the equation, and you've got the height. It's just the vertex. We know that the vertex is a maximum. If we find the vertex, we have everything we need. The x part of it is going to be the time, and the y part of it is going to be the height. Okay, now they gave us the full equation here. I know it's got a negative, so this is upside down. So all we're going to do is find the vertex, and then we'll answer their questions. So okay, I'm assuming that's 4. Yeah, I believe it is. Okay, so h is 4. Now how do we find k? We just put it back in the equation. So we've got negative 16 times 4 squared, 128 times 4, plus 32. Okay, so I'm going to get negative 256. All right, I get 288. So what does this vertex mean? It means it's the maximum. This is the maximum height. So 4 is the time. So the maximum, the time it takes to reach the maximum height is 4 seconds. The maximum height is 288 feet. Okay, we'll do it again. They've got our equation all set up for us. So all we need to do is find the vertex. So the double negatives are going to cancel out. Let's see if that divides evenly. Well, 6.5. So we get 6.5 for h. Now to find the k part of the vertex, we're plugging it back in. Okay, got to crunch this. And we get 676. Okay, so I've got the value of the vertex at 6.5, 676. Now in the context of a word problem, that means the time to get to the highest point is 6.5 seconds, and that height is 766 feet. Okay, there weren't a whole bunch of those, but they're always exactly the same. All you have to do is find the vertex, and by finding the vertex, you know the time and the maximum height.